in this video lecture, we will cover the topic such as the Tf Idf and working with the graph data. So these are the topics from the shaping data from the unit number 3. So let's start with the first one, that is what the Tf Idf is. So what is the full form of Tf Idf? So Tf stands for the term frequency and the IDF stands for the inverse data frequency. So what the term frequency is? So it gives us the frequency of the word in each document. The frequency of the word means how many times that particular word is repeating in our document. Suppose I'm using the LJ word 5 times in my document, then what is the frequency of the LJ word? The frequency of the LJ word will be 5. So that is what the term frequency is. The next one is the data frequency. So inverse data frequency, that is IDF, that is the inverse data frequency, that is IDF. It is used to calculate the weight of rare words across all documents. So the term frequency gives us only the frequency, that is the total count of the word, and the IDF gives us the total probability, that how many times that particular word is repeating in our document. So what is the probability of that word? So it gives us the probability. Suppose in my documents I have 10 different words and suppose my LJ word is repeating 5 times, then what is the probability of the LJ word? That is 5, that is count of the LJ word divided by the total number of words in the document, that is 5 divided by 10. So my probability of the LJ word is 0.5. So IDF gives us the weight of the rare words across all the documents like this. Now, so let's see now the Python code for the Tf IDF. So this is my Python code for the Tf IDF. Let's see that what is the input and what is the output. So you will understand that what is happening in the Tf IDF, and then we will understand the Python code line by line. So this is my documents, that is my documents object. It is my list. This list contains various different strings. So this is my first string, that is a vapor, comma, Bangalore has a really great terrace sitting and an awesome view of the Bangalore skyline. So this is my particular first statement, first string, and it is separated by comma. After that, my second statement starts. So this is my second statement, that is the beer at Vapor. Bangalore was amazing. My favorites are the wheat beer and the alley beer. This is my third statement in my particular list. So these are my 3 different statements, that is the string statements. Now let's consider this particular 3 statements as my document. So let's consider this particular first statement as my document at index position 0. This is my document at index position 1 and this is my document at index position 2. So in my documents object, I have the combination of 3 different documents. So it is told over here like this, that let's build a basic bag of words model on 3 sample documents. So they are telling this particular 3 statements as the 3 sample documents. So this is my document 1, 2 and 3 like this. So I am printing the documents object and you can see the same thing will be printed in my output cell. Now what is the output? Let's see the last output. So this is my last output of the Tf IDF. So in my Tf IDF, my bags of model, that is the bags of words vectorization will be created. So this is my bag of words, that which words are present in my above sample documents apart from the stop words. So in my above sample documents, it is the combination of the different words and the stop words also. So what is the stop words? The stop words are a and the, at is there. So what is the stop words that we have seen in the previous video lecture? If you have not gone through the previous video lectures or related to the stop words, then please go to that lecture and then come over here. So first of all, my bags of words model will be created. So it is the collection of all the words minus the stop words. So it will not contain the stop words. So after the subtraction of the stop words, these are my list of words which is present in my above three sample documents. So these are my words which is present, and this particular number, that is 0, 1, 2 and 0, 1 and 2, shows me the index position of the documents. So my first document is at my index position 0, the next document is at my index position 1, and the last document is at my index position 2. Now in the first document, you can see that ALE, this particular word is not used in my first document, so its probability is 0. The amazing word is also not used in my first document, so its probability is 0. So these two words are only used in my second document, that is the document at index position 1, that is 0.2 and 0.27, you can see. So in the last document also, my this two particular words are not used, that is the ALE and amazing. So let's see in the above three sample documents that where the ALE and amazing word is used. So you can see the ALE word over here, which is present in my middle statement. That is my statement, that is my document at index position 1. And you can see that ALE word is not present in the third document, and it is also not present in the first document. Also, the amazing word is present only over here in the middle statement. It is not present in the first statement. It is not present in the third statement. So you can see over here that the amazing word is only present over here in the middle document. It is not present over here in the two documents, so its probability is 0. So like this, it gives us the probability of various documents, various words used in the each document. So if I want to find out that these three documents are talking about which common topic, then you can say that this three document contains the word Bangalore. So this Bangalore word is present in all the three documents. So what is the common thing from all the three documents? That they are talking about the Bangalore. And which other words they are talking about? So you can see over here, if I minimize it, that vapor word is used over here. So all the three documents are talking about the vapor also and the Bangalore also. And you can see the probability of various words in the other documents like this. So like this, you can find out that what is the main content which is present in any document which is given to you. So like this, you can find out that which words are more frequently used from the WhatsApp chat or from the Facebook Messenger. So like this, you can perform the analysis based on the chat application also, or based on the SMS also. So let's understand the code now, that is the Tf Idf code. So first of all, I am loading all the necessary libraries, that is my pandas library, my natural language processing toolkit, that is NLTK library. From that, I'm importing the word tokenize and the stop words. And from the sklearn library, I'm importing this Tf Idf vectorizer. You did not have to write this particular code. I'm providing you this shaping data Python notebook file to you on your shared drive link. You can find that particular link in the description box below. So just understand the code and try to run it on your system. So this is my particular document object. So I have the sample of three different documents, that is this three sample documents. You can take any statement of your choice also. So this is my just three different statements. Now for this particular program related to the Tf Idf, what you need to do is just go to the Anaconda prompt. In Anaconda prompt, you have to write all this. What you have to write in Anaconda prompt, just close your Jupyter notebook, open your Anaconda prompt and write down Python and just press enter. So you will get such type of double greater than sign after pressing the enter. Then you have to write import NLTK, then again press enter, and then you have to write nltk.download punkt. So it is the library which contains the English words vocabulary. So we need this library over here, so we are importing it. So this is my Potter stammer class. So this class where we have used in the concept of the stemming. So what we are doing, we are removing the stop words from the above three sample documents. So for that we are performing this particular task. So we are importing the Potter stammer class and we are creating the object of the Potter stammer class. This is my user defined function, and user defined function name is the preprocess, and as an argument I am passing the document. So the first thing what I am doing that I am changing my sentence to the lowercase. So I want to find the, if I want to find the probability of the Bangalore word, then in some document the Bangalore word is written in the capital letter. In some document the B is capital of the Bangalore. In some document all the Bangalore words are in the lowercase. That then at that time the Python, what the Python is doing, the Python will consider all the words as the different words. So to avoid such kind of complexity, what we are doing, we are changing our sentence to the lowercase. So I am writing document.lower. So what is this document? This document comes from here. So whatever document you are passing as an argument, that will be converted to the lowercase, and that I am storing it into my, again, the document object. So whatever the document is, it will be replaced by this particular document.lower. So in my document, now all these statements are present in the lowercase. Now what I am doing, I am tokenizing the sentence into the words. So in the previous example of the stop words, what we have done, that we are using the split function for this tokenization. But over here, we can directly use the word underscore tokenize function that we have imported, from the natural language toolkit. It is already present, that is word underscore tokenize, and I'm passing the document. So what will happen? The complete statement is divided into small chunks of the words, and it will be stored in my words object. Now I am making use of the Python comprehension, and I am trying to remove these stop words. So what will happen? I am writing that for word in words. So my this particular object will be created, that is word. It will find out in the words. Turn by turn all the words will be taken, and it will check whether the stop words is present in my that particular words object or not. So like this my stop words will get removed. So how this particular statement is working, you can check the previous video related to the stop words. In that I have explained that how this particular statement is executing. So this is how you can remove the stop words. Then what I am doing over here, that I am joining words back to make the sentence. So for that I am making use of the join method. So in the finally, I get the document in which the document contains only the lowercase and the stop words gets removed. So I am replacing this value, and this is my document, and I am returning this document, that is the written document, like this. So this is my user defined function, that is the preprocess, and I am calling this function, that is preprocess, into the bracket I am passing document. So I'm writing for document in documents. So for where this documents came from, this documents came from here. That is my three sample documents. That is my object name is documents. So what will happen? Turn by turn, every document will be passed over here. That is for document in document. So the first document will be taken. It will be passed into the pre-processed document, and whatever the final result is, that will be stored in my final object called documents. So this is what the output of the documents is. So you can view like this. So it contains the statements in the lower case, and these stop words are removed. So this is how my final document after the pre-processing looks like. Now creating a bag of words model using the count factorizer function. Now I want to perform the Tf Idf. So I want to find out the weight of each and every word. So for that I am making use of the Tf Idf factorizer. that is the class, and I'm creating the object that is the vectorizer of this particular class. So this particular is the inbuilt class which is present in my sklearn library. So you can see over here that I have written the sklearn.feature underscore extraction dot text, that is Tf Idf vectorizer. So what I am doing over here is I am writing this particular object that is vectorizer dot fit underscore transform documents. So what this fit underscore transform is doing, it will learn the vocabulary dictionary and return the document term matrix. So it will learn the vocabulary dictionary. So whatever the words are present in your sample documents, it will create a dictionary from it and it will return the final matrix. So with the help of this vectorizer object, I am calling this method, that is object dot and the method name, and as an argument I am passing my sample documents, that is my this particular documents object. So I will get the final result and it will be stored, that is the matrix will be stored in my Tf Idf underscore model, and I am printing this Tf Idf underscore model, and this is my output. Now let's see that what this output shows. So this returns the row number and the column number of the cell which have the non-zero value. It means which have the 1 as the value. It means the non-zero values. So in the document 0, so the first index shows your the document index position. So in my first document, which is at index position 0, so it is showing me the 0 0 like this. And the second shows the index position of the word. So in the first document, the word at the 10th index position has the probability like this, that is 0.34. In the first document, the word which is at index position 2, it has the probability like this, that is 0.3466. In the middle document, and the first word has the probability like this. In the middle document, the word at the index position 3 has the probability like this. Similarly, in the last document, that is the document at index position 2, the 13th word has probability like this. So what I am doing, I am converting it into a full sparse matrix. So I am writing Tf Idf underscore model, that is my this particular object dot to array. So what will happen? It will give me now the probability of all the words. So you can see over here when I am converting it into a full sparse matrix, then you can see the zero count in it. So you can see the first two words have the probability as 0, which is not present over here. So this particular Tf Idf underscore model will give me the output which has the value as non-zero. So you can compare over here that the first document which is at index position 2 has probability 0.3466. So you can see over here that this is at index position 0, this is at index position 1, this is at index position 2, and its probability is 0.3466. So which is mentioned over here, that is 0.3466. You can see that 0 comma 3, after 0.3466 we should get the value like this, that is 0.40945. So you can see 0.40945 like this. So I got the full sparse matrix of all the words present in my document. Now this particular array, one can't read, the person who does not have the understanding of the Python can't read this array. So what we are doing, we are converting this array into the data frame. So for that I am using the pandas function, that is the pd.dataframe. I am passing this particular full sparse matrix, that is Tf Idf underscore model dot to array, and I want the columns, that is the vectorizer dot get underscore feature underscore names. So what is this vectorizer? This is my object, that is the vectorizer object from here. So it will take all the unique words, that is the unique feature names which is present in my sample documents, and it will be my column labels. So I'm writing columns equals to like this. So in the column label I will get all the unique words, and in the row I will get the index position of the sample documents that I am having. and like this you will get the probability of all the different words. So you can see the matrix like this, that is first two values are 0. So you can compare over here that first two values are 0 over here. Then the third value is 0.3466. So you can match over here. The next value is 0.409 like this. So you can match over here like this. Then again the two values are 0 like this. So this is how you can find the weightage of each and every words. So how to read this particular matrix, that I have already told you. So this is what about the Tf Idf is. Now the next topic is in the unit number 3, that is the last topic, that is the working with the graph data. So in that we have to see understanding the adjacency matrix and using the NetworkX basic that we have already covered in the unit number 2. So we have to see only over here that what the adjacency matrix is. So let's understand its topic, that the matrix represents the connection between the nodes of a graph. So when a connection exists between one node and the other, the matrix indicates it as a value greater than 0. So let's understand it with the help of the Python code. So this is my Python code. What I am doing, I'm importing the NetworkX library and I'm creating the graph. So my graph is cycle underscore graph and it contains 10 different nodes. So I'm writing nx dot cycle underscore graph and I'm storing it into my object called G. Now to create the adjacency matrix, I am writing nx dot adjacency underscore matrix. I want to create adjacency matrix of which graph? So I want to create the adjacency matrix of graph G. So I'm passing G as an argument, and whatever the final result is, that will be stored in my object A. So in my object A, what will be stored? My adjacency matrix will be stored. To print the adjacency matrix, I am writing A dot toDense. So let's run this particular cell and you can see the output in the form of the matrix. So this is my output. So what this output shows? The output shows that my node 0, which is connected with my node 1 and the last node. So it is showing the number as 1 and all other values are 0. So let's clear this particular topic by drawing the graph. How to draw the graph? So I'm writing nx.draw underscore network x, and which graph you want to draw? I want to draw the G graph. This concept we have already studied in the unit number 2. So to plot the graph, I am writing plt.show, which is completely optional, that is the plt.show. So this is my graph and you can see that this is my cycle graph. So this is my node 0. It is connected with which other nodes? It is connected with the node 1 and the last node, that is the node with number as 9. So you can see that this is my adjacency matrix for the node 0. So it is connected with the node 1. So it is showing me the 1 over here, that is at index position 1. And the 1 is at last index position. So it is connected with the 1 and the 9 like this. Then if I consider the node which is like this, that is the node with number as 1. So this is my second line. So this particular node is connected with which different nodes? So you can see that 1 is written in the first column. It is my column with index position as 0. So this particular node is connected with the node 0 and it is connected with node 2. That is my column with index position 1 is indicated as 0 and column with index position 2, it has the value 1. So my this particular node 1 is connected with 0 and 2. So like this you can identify that which node will be connected with which different nodes. So if I take the example of the node number 9, then it is connected with which different nodes? It is connected with the node 0 and the node 8. So this is connected with node 0 and node 8 like this. So this is what the adjacency matrix is. Now if I add one age, that is 1 comma 5 in this particular graph, that is my graph G, then what will happen? One age will be created between 1 and 5. So what will happen? This particular ring is there. When I create one age like this, so what will happen? Two different rings will be created when I join these two particular nodes. So let's run this code, and you can see that this two nodes is now get connected with the help of an edge. So now I am getting two different rings in my graph. So this is what about the working with graph is. You can use any of these books as you want. This is the technical publication, and this is the reference book as per your GTU syllabus. That is the first reference book, that is the Python for Data Science for Dummies. So keeping it still here, thank you for watching.